Good afternoon, everybody, and good morning to those in Korea. Thank you very much for joining us. We really appreciate it. My name is Mark Plamondon. I'm the Executive Director of Alberta's Industrial Heartland Association. And we've been working in collaboration with the Transition Accelerator, Edmonton Global, and all levels of government to help develop a robust hydrogen economy. In fact, the Edmonton Region Hydrogen Hub was just announced yesterday, and we are excited to be a partner in that initiative. Part of the vision of a robust hydrogen economy is hydrogen exports to various markets. And this is the third of a series of webinars to explore those markets. The first webinar dealt with Japan, the second was with California, and we're excited today to talk about Korea. I would like to express my appreciation to Dr. Nakwon Kwon, General Director of Business Coordination Center, H2 Korea. I'd also like to thank the staff of the Alberta Korea office for playing an integral role in coordinating this webinar. So today's session is in presentation format. Dr. Kwon will give us a presentation on the Korea hydrogen market, and we'll follow that with questions and answers. So I would ask everybody to type their questions into the chat. I will try to put those questions into themes and then present those questions to Dr. Kwon. And with the remaining time in the webinar, I will present some slides on Alberta's Industrial Heartland and the opportunity for hydrogen investment here. So before turning it over to Dr. Kwon, I would like to ask Her Worship, Alana Nachu, Mayor of Sturgeon County and the Chair of Alberta's Industrial Heartland Association and the Chair of the leadership team for the Edmonton Region Hydrogen Hub, to say a few words. Mayor Nachu.
Thank you and good afternoon. And thank you for joining us here today to learn more about the Korea hydrogen landscape and their market needs for low cost, low carbon hydrogen. As stated by Mark, my name is Alana Nachu and I'm chair of the Alberta's Industrial Heartland Association and chair of the leadership team of the Edmonton Regional Hydrogen Hub. Hydrogen may be the smallest molecule, but we know it has the potential to have a truly historical impact on the future of energy in our region, our province, and our country. Alberta's Industrial Heartland is among the world's lowest cost producer of low carbon hydrogen, and in fact can be produced at about half the cost of diesel. With access to low cost natural gas, existing experience in hydrogen production and carbon capture and storage, as well as a vast network of pipeline infrastructure, a large talent pool of engineers, tradespeople, and engaged industry partners, government, Indigenous, and academic leaders, the Edmonton region is well positioned to capture and maximize the hydrogen opportunity on every level. Hydrogen is redefining how we use our natural resources, and I am proud to say that my colleagues and I at the Edmonton Region Hydrogen Hub are working together to advance a shared goal of accelerating a strong pan-Canadian hydrogen economy and working towards a goal of making Canada a leading user and exporter of low carbon hydrogen. So how do we do that? One way is through demand export markets. Today's session will help us to understand where the potential lies and how Canada can take advantage of the tremendous export opportunity in hydrogen. Dr. Kwon, thank you very much for joining us today, and I look forward to hearing your insight on this critical topic.
Thank you.
Thank you, Mayor Nachu. So I'm pleased to introduce Dr. Kwon. He's General Director of Business Coordination Center, H2 Korea. Dr. Kwon majored in environmental engineering, the master's and doctorate degrees in electrical chemistry. He joined the Hyundai Motor Group in February 2005 to conduct research on the development of systems for hydrogen fuel cell vehicles and electric vehicles in the field of eco-friendly vehicles. He worked as a senior researcher until 2009, developing the design and manufacturing technologies of fuel cell systems, and then as the part leader of the membrane electrode assembly development until 2013. And as a result of all this research, he published about 10 papers, 24 US patents, and 26 domestic patents. He was then dispatched to H2 Korea in October of 2018 to plan and support domestic and international cooperation projects for the development of the hydrogen industries. So we're very excited to have Dr. Kwon with us here today. And Dr. Kwon, I'll pass it over to you. We look forward to your presentation.
Thank you, Mark. Yeah, good afternoon. This is Nakhen Kwon. I am the General Director of Business Coordination Center at H Korea. First of all, I would like to thank the Canada embassies in Korea and the Alberta AIHA for hosting this webinar for the cooperation between Canada and Korea's hydrogen industry. And I wish the participate safe during the time of the coronavirus outbreak. I am honored to introduce the current state of the hydrogen industry in Korea at today's meeting. Recently, major countries around the world are paying attention to hydrogen as future energy for the environment. Korea also presents Korea's vision for the future hydrogen economy through the announcement of the hydrogen economy roadmap in January 2019, and announced the Korean type New Deal in July 2020, and aim to convert it into a hydrogen economy with the development of the new and renewable energy. Okay. Now I will start the presentation of the topic of Korean hydrogen strategy. First, let me introduce H Korea. H Korea was established by the government and the private companies to develop the hydrogen economy. H Korea is an organization dedicated to promoting the hydrogen industry in South Korea. It was originated by the Korean government on July 1, 2020. HK's main role is to support the policy development and the improvement required by the hydrogen economy society, and to push forward the demonstration project by reviewing sustainable hydrogen energy business models. It will also support expansion of supply of hydrogen electric vehicles, expansion of hydrogen refueling stations, and the establishment of hydrogen production and the supply networks. It also supports international cooperation projects for the development of the hydrogen industry and the research and development projects necessary for public promotion and the utilization of hydrogen energy. Yeah, this slide, H Korea has 104 members, including the central government, local government, companies, research institute, academic societies, and associations. Okay, let me explain the roadmap for Korean hydrogen economy. Moon Jae-in president in January 2019 about the South Korea hydrogen economy announced the roadmap. It also declared the vision to become the world top-class country in hydrogen economy. The Korean government divided the hydrogen economy promotion system into 3 stages by 2040. As a first step, it is a preparation process for the hydrogen economy by 2022. Since 2018, the government has been making effort to create policies to boost the hydrogen industry, expand the supply of hydrogen cars, and build hydrogen refueling stations, and create law and systems. The foundation for entering the hydrogen society will be set up by 2022. The second step is to create a hydrogen economy by expanding the hydrogen industry. To that end, Korea is working on projects including hydrogen cities, expansion of infrastructure from hydrogen production to storage, hydrogen ships, and hydrogen trains. By 2030, we will see a model of a hydrogen economy society in Korea. Finally, it will achieve leadership in the hydrogen economy by 2040. Green hydrogen without CO2 emissions will be mainly supplied at this time, and the necessary hydrogen is also being considered for import from abroad. Okay, let me explain the goal of the Korean hydrogen economy roadmap. As shown in the chart, hydrogen car will produce 18,000 units per year by 2022 to 620,000 units per year by 2040. Hydrogen refueling station will build 310 units by 2022 and 1,200 by 2040. Fuel cell power generation currently stands at around 373 megawatt and will be increased to 1.5 gigawatt by 2022 and to 50 gigawatt by 2040. Calculating the hydrogen supply at this rate required 417,000 tons by 2022 and about 5.3 million tons by 2040. Therefore, mass production and the supply of hydrogen is important in the future. Currently, South Korea produced and supplied hydrogen for byproduct and LNG reforming. However, it will expand the production of green hydrogen after 2030. In addition, Korea is developing the water electrolysis technology and is also considering importing insufficient hydrogen from abroad in the future. Okay, Korea is carrying out many projects in the storage and the transportation sector of hydrogen. It is also developing hydrogen cars, ships, trains, power generation, and hydrogen cities. In particular, hydrogen cars, ships, train, and power generation are being developed with the goal of high economy and high performance. Hydrogen cars aim to produce about 100,000 units in 2025. The hydrogen fuel cell power ships aim to develop large-scale transportation ships by 2030. Also, diesel train and tram are being developed and the hydrogen train. Okay, recently the government finalized its roadmap for hydrogen technology and announced it on October 2019. Through the announcement of hydrogen technology roadmap, Korean vision was to become a leading hydrogen economy by securing world-class technology. Okay, you can see here. First, in the hydrogen product sector, the government set a target of setting the currently hydrogen demand at 5.26 million tons per year in 2040, and lowering the average supply price, including transportation cost, by $3 per kilogram. In the storage and the transportation sector, the government will upgrade the technology for storing and transporting gas hydrogen to lower the cost of transporting trailers by $0.7 per kilogram. In the period of utilizing Korea had set up a plant to commercialize medium and large hydrogen construction machines, hydrogen trains, hydrogen ships, and hydrogen drone for large-scale logistic transportation by 2030. To that end, Hyundai Motors will expand the fuel cell technology of its hydrogen fuel cell vehicles, which are globally compatible. To promote the supply of a fuel cell system for power generation, such as home, building, distribution, generation, and large-scale power generation. The government plan to focus on lowering the installation cost of unit cost. The cost of installation fuel cell for a home building in currently about 27 million won per kilogram. It will be lowered to 5 million won Korean by 2030, and 60 million won by 2040. The unit cost to the large-scale power generation in current 241 won per kilowatt hour. It will be lowered to 100 per one in 2030 and about 131 in 2040. In the sector of safety, environment, and infrastructure, the government has set up a plan to prevent hydrogen accident and assess safety. And to that end, the government plan to complete the construct of a database of hydrogen materials and component by 2030. Okay, the government announced its strategy for developing the future automobile industry on October 2019. The main content of the automobile industry development strategy as a payload of all electric vehicles, including hydrogen electric vehicles, have achieved 33% of sale share of vehicle in Korea, and set a goal of achieving 10% share in global market. In particular, the government planned to expand the lineup of hydrogen vehicle content on SUVs and large trucks, and achieving a durability of 400,000 kilometers by 2022. It also planned to lower the price of hydrogen vehicles to around $40,000 US. Hyundai Motors Group present its FCB vision and announced a long-term roadmap for 2030. It has set up a plan to produce 700,000 fuel cell systems by 2030, including 500,000 FCB per year. In addition, Hyundai Motors Group said it would invest about $7 billion US by 2030 to develop the FCBs. Okay, this is Nexo. Let me introduce Nexo, which was mass-produced by Hyundai Motors in January 2018. Nexo has made many technology advantages compared to the Tucson FCBs, which was mass-produced in 2013. Compared to Tucson FCB, output performance is improved by about 20%, and system efficiency is improved by 10%. And it increased durability and low prices. It also starts at -30 degrees and can run 609 kilometers on a single charge. Okay. Also, the status of development of large hydrogen cars, such as truck and buses in Korea. Recently, the government has been expanding the distribution of buses in the city to hydrogen buses as part of effort to reduce pine dust in the city center. It also plans to develop and distribute hydrogen cars to large truck weight more than 5 tons. Hyundai Motors Company has developed a hydrogen city bus and plan to distribute 35 units to 6 cities, including Seoul, by this year. The hydrogen truck was also developed and applied to garbage collection vehicles, and will be operated in Changwon City. In addition, Hyundai Motors signed a supply contract with H2 Energy of Switzerland for 1,600 hydrogen trucks. Okay, let me tell you about the current state of the hydrogen economy in Korea. Korea's hydrogen economy operated about 12,000 hydrogen cars, 100 buses, and 21 taxis are in service. And 1,517 FCBs were exported exported as of October 2019. The picture right and below show the operation of hydrogen taxis, hydrogen bus, fuel cell power plant, and they show hydrogen refueling station built in Korean National Assembly. And 81 hydrogen refueling station has been built across the country, with about 118 hydrogen refueling stations scheduled to open by this year. Currently, fuel cell power generation has 53 plants in Korea and produced about 464 megawatt electric power. In particular, it is supplying 7.1 megawatt power to building through fuel cell power generation. Okay. Yeah, Korea has set up a plan to build a nationwide hydrogen charging infrastructure network along with the expansion of domestic hydrogen car supply and announced a strategy to develop hydrogen refueling station in October of last year. We are reviewing various refueling methods and the transport method for hydrogen based on the purpose, considering the operation and the economic of hydrogen refueling stations. Currently, most of high-pressure hydrogen refueling stations are located, but in the future, stations using liquefied hydrogen will also be built around the city center. In addition, hydrogen transportation will be diversified not only by tube-to-rail transportation, but also by pipeline transportation and liquefied hydrogen transportation. Korea is planning to build hydrogen charging infrastructure by considering economy feasibility, scalability, and regional characteristics by expanding hydrogen charging stations. By 2030, 616 hydrogen stations will be built in major part on the country. Also, we are going to build hydrogen produce facilities in the major basin across the country. In addition, 1,200 units will be built nationwide by 2014, including 200 hydrogen refueling stations on bus. This will allow hydrogen car drivers in major cities across the country to use hydrogen charging station within 20 minutes of wherever they are. Okay, as you can see here, Korea is pursuing a specialized hydrogen industry project, such as hydrogen related cities, hydrogen producing clusters, R&D specific city, and hydrogen mobility clusters. There will be more projects coming up, and by 2030, there will be a visible hydrogen society. Okay, this chart shows that in order for the hydrogen industry to grow, economic scale must be realized. The graph on the left shows that the price of hydrogen cars trend to decreasing in conjugation with the supply of vehicles, which is expected to fall to the level of conventional internal combustion engine cars around 2025, when more than 100,000 units are produced annually. The construction cost of a fuel cell for power generation is currently around 20 million Korea won per kilowatt, but the construction cost is expected to continue to decrease as the construction of a power generation facility increases. the transition to a hydrogen society has many advantages in reducing greenhouse gas emissions and improving environment problems. The growth of a new industries can also lead to the expansion of the new job market and to nation the value added. Uh, this chart shows the scalability of the fuel cell. The technology of hydrogen car fuel cell system can be applied to various hydrogen mobility. By doing so, the hydrogen fuel cell market will grow in a short period of time, and the price will be reduced through mass production, thus securing to economic feasibility of the hydrogen industry. And we can apply it to home and the industrial fuel cell to create new industries and market. However, in order to become a hydrogen society, it is difficult to grow by considering only one country. International cooperation is more important than anything else. The global hydrogen economy will be realized only when countries cooperate with each other in their strengths and technologies and grow hydrogen markets together. As Korea will expand its global hydrogen industry cooperation network with hydrogen promotion organization around the world, it will support information exchange and global technology cooperation with hydrogen association and international organization in each country and service as a bridge between the government and the private sector through a cooperative network. As mentioned earlier, uh, a Korean plan to push for the introduction of hydrogen, which is lacking after 2030. To this end, the Korea government set up a plan in July 2020 to build an overseas hydrogen supply chain as a way to issue sustainable hydrogen economy. Through this, we believe that Korea will be promote sustainable growth of the hydrogen industry by securing a stable hydrogen supply chain and the future contribute to energy security and the stabilization of hydrogen prices. The government has set up a three-step stage to introduce CO2-free hydrogen overseas. As a first step, we will conduct a feasibility study for 1 year. In this process, we will investigate the future CO2-free hydrogen production country and analyze economic, environmental, and technology feasibility according to hydrogen production and the transportation method by country to live domestic introduction scenarios. Based on the first stage feasibility study, the second stage will be a demonstration project involving companies and will be carried out for about 5 years. Phase 3 will select a project that has been proven to be possible in phase 2 to promote commercialization by 2030. Then I will explain the feasibility study for the introduction of CO2-free hydrogen overseas. For your information, the first phase of a feasibility study will be conducted by H2 Korea from the end of this year as a government project. First of all, hydrogen produced will conduct 3 dimensional analysis of technology, development, and economy for all stages of domestic import and distribution, and the focus of customizing a feasibility study for each country for the introduction of hydrogen abroad. To this end, we will draw up a basic concept design for hydrogen production storage, transportation of import-export terminals by technology reviewing a coming model for hydrogen introduction unit price. Select a core storage country for hydrogen introduction and prepare a scenario for CO2 introduction. Afterward, we will select potential hydrogen produced and establish a hydrogen introduction portfolio to provide feasibility of a demonstration project through phased implementation strategies. Therefore, Korea will consider various reviews such as hydrogen production potential, storage, overseas transportation, import and export terminal, and infrastructure of origin produce, and will review cooperation plans with Canada, Australia, South Arabia, UAE, Russia, Norway, and New Zealand, etc. After review, we will select major part countries and conduct feasibility study on demonstration project. A lot of cooperation is being discussed with Canada, which would host the conference. In particular, we have to the two countries will lead the hydrogen market by establish the hydrogen cooperation relationship in hydrogen production, transportation, and hydrogen industry and utilization using renewable energy. Okay, thank you for your attention.
Dr. Kwan, thank you very much for the presentation. Lots of information there, very interesting, very relevant, I think, to all of the viewers here today. So there's a number of questions that have come in on the chat, and I'll ask them to you, and hopefully you can provide us some further insight. So some of the questions that are being asked are around the preferred type of hydrogen, whether it's liquefied hydrogen or organic carriers or ammonia. Is there a need for all types of hydrogen carriers, or what's your view as to demand for the different types of hydrogen that could be delivered into Korea? Dr. Kwan, did you hear my question?
Oh, sorry.
Did you hear my question, Dr. Kwan?
Yeah. The consideration of introduction hydrogen overseas in Korea is what type of hydrogen is import. First of all, liquefied hydrogen is difficult in the short term because the transportation ship and storage transportation technology are not optimized. The same goes for MCH. Therefore, ammonia or transportation technology is commercialized, can be the first alternative. It is expected that liquefied hydrogen or MCH transportation will gradually increase when commercialization technology that secured economic feasibility in the field of transport of storage of liquefied hydrogen is development after maybe 2030 or 2040 years.
Yes,
Just
so carry on. Continue, please, Dr. Kwan.
yeah, you can question to ammonia. How can to why? One more
Sorry.
time to yeah.
So if I understand correctly from your question on the answer to ammonia versus hydrogen, et cetera, there's limitations on transportation of hydrogen at the moment. And ammonia has some technology advantages relative to liquid hydrogen with respect to transportation. Because there's some questions right now about what's the status of the availability of hydrogen transport ships. Perhaps you have some comment on when you'd expect hydrogen to be imported into Korea as liquid hydrogen versus ammonia, and the availability of hydrogen transport.
Yeah, I think so. We start to ammonia transportation, maybe start to 2025. Maybe some we after feasibility study we can demonstration and liquefy hydrogen transportation. Maybe some I think the 2030 after 2030 some start to demonstration. I don't know exactly, but this is some we can R&D technology through to liquefied hydrogen.
Okay.
Yeah.
Great. Thank you. There's some questions around production of hydrogen in Korea versus imports. So you mentioned by 2040, there's a demand for 5.3 million tons per year of hydrogen. How much of that do you expect to produce domestically? How much do you think you'd need to import between, say, 2030 and 2040? Do you have any numbers on imports versus production?
We have now detail this value we check because we have to need to total hydrogen is not fixed. Okay, just maybe 1 million ton in 2030 is we can lead to the abroad importing abroad, and so maybe I don't know exactly. The Korean announced the hydrogen roadmap predict the hydrogen will account for about 5% Korean total energy by 2040. Currently, Korea is preparing the present more specific figures this year, declaring carbon neutralized. I think so. I can't tell you by the end of this year. Just we can some information. This we have Green New Deal. The ratio of greenhouse gas emission in Korea is 37% for power generation, 35% for industries, 14% for transportation, and 7% by for building. Considering this, hydrogen use is currently concentrated in the transportation of power generation sector, but the proportion of hydrogen used in expected it to increasing certificate after 2030 due to the power generation and the industrial energy. Just I think so. Maybe 2030. After 2030, so many need to the hydrogen. Yeah.
Yeah. Do you on the import of hydrogen, do you expect, is there an anticipated carbon intensity target? Do you think Korea will be focused mainly on importing what's called, green hydrogen, or will they just be looking at a carbon intensity? If it's hydrogen that's produced using carbon capture, that will meet the needs of Korea. Do you have any comment on carbon intensity targets?
Yeah. We have a target after we started 2030. After 2030, we start green hydrogen produce. But now this green hydrogen is so expensive to price. Just we can step by step to develop the water electrolysis technology. Increasing its efficiency or some capacity, some increasing. Just we expected to the import hydrogen, also blue or green hydrogen. But I know this green hydrogen now so expensive because first we have started to the blue hydrogen used by blue hydrogen, and then more enough to the price or just some capacity of green hydrogen, and then we can exchange to the more than increasing importing green hydrogen.
Right.
Yeah.
Right. So if I understand what you're saying, given the price of green hydrogen at this point, you'd expect Korea to import blue hydrogen and then transition over time, if I understand correctly.
Yeah.
Are there some specific import price targets for hydrogen that you think Korea will be looking for in 2030 or 2040? Do you have any comment on price of what you'd be looking for? Any thoughts on that or comments?
Yeah, Korea is setting its hydrogen price target for 2040 at maybe $3 or $4 per kilogram. Therefore, the price of hydrogen being introduced overseas is less than $3. Maybe. Yeah.
Okay, interesting. Certainly, the transportation costs are a big component of that. It always comes down to logistics, I think, when importing. Question around, there's a number of questions here. I'm trying to capture them as best I can. Question around production of hydrogen in Korea. What plans would there be for carbon capture and utilization and storage from hydrogen production from natural gas reforming? Is there CCUS capability in Korea, or what's the thoughts? I think in your strategy in the first few years, you're talking about hydrogen production from natural gas reforming. There's questions around carbon capture and storage. Do you have any comments on that, Dr. Kwon?
Yeah, Korea is not CCS and CCUS not possible to not store it. Just we maybe Canada or others, lead to the CCU and CCUS. Just we can yeah. Now we can energy reforming also some just green hydrogen, not blue hydrogen.
Yeah. Okay. There's a question in the chat about the cost of hydrogen versus gasoline in order to substitute and become a transportation fuel. Do you have an indication of price ratio between hydrogen and gasoline expectations in Korea?
Now it's compared to the gasoline with hydrogen. Yeah, hydrogen now is some similar or the lower, but we can target more the decreasing to cost price. Now $7 per kilogram, but after 2040, we will target is $3 US dollars per kilogram. Yeah.
Okay. And in your strategy, you're looking at a number of countries as source of hydrogen, Canada being one of them. Do you have any bilateral, how many bilateral arrangements? One of the questions is how many bilateral arrangements do you expect for your supply mix of hydrogen? Basically, do you expect to reach out to multiple countries for your hydrogen supply? Do you expect to target one or two countries? What are your thoughts on hydrogen supply and bilateral agreements?
Yeah, now we can contact possible production of hydrogen country. We can try to the now. I don't know fixed. Yeah.
Yeah. Well, I have about 13 minutes left here. Maybe I can, share with you and others on the call from Korea about some of the advantages of hydrogen production in Alberta's industrial heartland for supply to export markets. So maybe I'll put a few slides up. We still have some other questions. If you don't mind, I'll email those to you, and maybe we can get some answers for the attendees, and we'll send them out to the attendees in the future. There's a few other questions that haven't been answered, but I think you could provide some good answers to. Is that okay?
Okay.
Excellent. I'm going to share my screen and provide a few comments around hydrogen production in Alberta, okay?
Okay.
All right. Okay, so Alberta's industrial heartland, we think that there's really strong value proposition to the supply of hydrogen to export markets. For those who on the call who are not familiar with Alberta's industrial heartland, our association is guided by, it's a nonprofit association guided by 5 municipalities with 3 associate members: City of Fort Saskatchewan, City of Edmonton, Strathcona, Sturgeon, Lamont counties, and then we have 3 associate members: towns of Gibbons, Redwater, and Bruderheim. What our association does is we work with companies, many international companies looking at their next capital investment. And in this example, we're looking to work with companies who are interested in investing in hydrogen production assets for exports to international markets. Alberta's industrial heartland spans 582 square kilometers. We are based here in the northeast corner of the Edmonton metropolitan region. Here are the 5 municipalities that I mentioned, and then the Alberta's industrial heartland spans 582 square kilometers. And there's over $40 billion of assets in the ground here as we speak, with over 40 companies operating in this jurisdiction. And again, for those on the call who are not familiar with our jurisdiction, there's substantial infrastructure here in midstream and utilities, in the downstream gas and NGL processing, bitumen upgrading and refining, and then other specialty chemicals and specialty products produced here in Alberta's industrial heartland. So we are a significant cluster here in Canada. We are Canada's largest hydrocarbon processing region, with a tremendous amount of inputs and outputs being processed amongst the various parties here in this industrial cluster. A number of world-class companies operate in our jurisdiction. And some recent investments are listed on this slide. ATCO is conducting a hydrogen blending project. Wolf Midstream recently completed the Alberta Carbon Trunk Line. Inter Pipeline is currently constructing their propane to propylene facility. Dow is constructing their ethylene plant expansion, and Canada Rail has completed a 302-acre rail yard, which became fully operational in September 2020. So what I'm communicating to those on the call here is that there's, a number of large-scale investments that have happened recently and tremendous opportunity for additional investment in our jurisdiction. And so, what are the competitive advantages? Why would companies look to Alberta's industrial heartland for an investment? One of the main reasons is the immense natural gas reserves in close proximity to our jurisdiction. There's over 200 years of supply at current production, and there's over 100 years of supply of propane at current production rates. So decades and decades of resources in the ground that are readily available, with infrastructure to transport from where the resources are in the ground to Alberta's industrial heartland. This here is just an illustration of pricing recently. The red line is Alberta pricing, the blue line is Gulf Coast pricing. The point that we're trying to make here is there's significant discounted pricing here relative to Gulf Coast. It is some of the lowest feedstock costs in North America and some of the lowest in the world. And this is the main competitive advantage for hydrogen production here in AIH relative to elsewhere in the world. It is the low cost of natural gas that drives the competitive advantage for hydrogen production. And just, looking forwards, we expect that discount, the cost advantage of Alberta relative to Gulf Coast, to continue given the structural advantage of our market relative to Gulf Coast. Another competitive advantage of our region with respect to the infrastructure that's here is the potential for underground hydrogen storage through salt caverns. So not all jurisdictions have the capability of salt cavern storage. Some do, but some do not. And we're very fortunate here in AIH that there's the geology is conducive to this type of infrastructure where companies can inject water into the salt formation to dissolve salt and pump the brine to the surface, which leaves an impermeable cavern for storage of energy products. And this is a real advantage for our region, we believe. And equally importantly, or maybe more importantly, is the infrastructure associated here with carbon capture, utilization, and storage. Significant CCUS infrastructure here in the industrial heartland with surplus capacity that enables additional hydrogen production and allows for tying into this infrastructure for the carbon capture storage here. The capital's already here, so there's capital efficiency associated with clustering and with additional investment in hydrogen production here. So between the low-cost feedstock, the salt cavern storage capability, and the carbon capture, utilization, and storage infrastructure, we believe that this jurisdiction is second to none globally for production of low-cost, low-carbon hydrogen. And there's a study conducted, a Japanese study in 2018, looking around the world where is some of the lowest cost hydrogen production capability in the world. Way down here at the bottom is Canada. So here in Alberta, we would produce some of the lowest cost, low carbon hydrogen globally. And so we believe that this is a real advantage and a real opportunity for exports to international markets. So whether the opportunity is with liquid organic carriers or ammonia or other carriers, these products can be shipped internationally. There is rail service from Alberta's industrial heartland to ports. The most likely port would be up here in Prince Rupert, where shipping time over to Asian markets is around approximately half the transit time than if you're coming out of Gulf Coast, and approximately 70% of the transit time if coming out of Saudi Arabia. So from a proximity standpoint, we believe that West Coast Canada is well positioned to move hydrogen and ammonia into Asia. And Alberta's Industrial Heartland can access the West Coast ports, of course, through CN and CP rail activity and links that we have. And in addition to all that, the government of Alberta has put in place what's called Alberta's Petrochemical Incentive Program. This is an incentive program to incent large-scale value-add investment that upgrades natural gas, propane, ethane, and propane resources in the province. And hydrogen is part of this program. So for a company to come into Alberta and build a hydrogen production facility that has carbon capture, utilization, and storage on the back end, you would qualify for this program, which would provide up to 12% of eligible capital costs back to the project proponent in terms of in grants over a 3-year period. So this is fantastic support from the government of Alberta. In addition to the government of Alberta, there is support from the municipalities in Alberta's Industrial Heartland called the Heartland Incentive Program. The 5 members of Alberta's Industrial Heartland Association agreed on a policy to augment and supplement the APIP program with additional tax exemptions for a large-scale value-add investment that upgrades Alberta's energy resources into value-add products such as hydrogen. So hydrogen investments would be applicable to this program as well. So in closing, for those on the call who are not familiar with our jurisdiction, low-cost feedstocks, carbon capture, utilization and storage infrastructure, salt cavern storage infrastructure, government support, regional collaboration. We think it's a jurisdiction that's second to none for hydrogen investments and investments in hydrogen production facilities. So that was a very quick overview, but I wanted to share those messages with those on the call from Korea who are not familiar with our jurisdiction. That brings us to a couple of minutes before 6:30 here. I would like to thank Dr. Kwan for spending his time with us. 8:30 in the morning in Korea. It's now almost 9:30. You'll be able to get on with your day, Dr. Kwan. Thank you very much for your presentation, and thank you to everybody on the call for attending. We will take all of the questions that came in. We did not get to all of them. We will provide them to Dr. Kwan and get answers and distribute them to all of the attendees when we get them. So thank you very much. We really appreciate everybody joining us here today. And for further information, please visit our website, and we'll happy to answer any additional questions at Alberta's Industrial Heartland and tie you in as well to the Hydrogen Hub for any further discussion or questions. So thank you very much, everybody. Have yourselves a very good evening.